In a galaxy teeming with billions of stars, each with its own story of formation, life, and often a spectacular end, it's easy to think we've seen it all. But every so often, the cosmos throws us a curveball, a cosmic event so extraordinary that it shifts our understanding of the universe. The recent discovery by NASA's citizen scientists of an object streaking out of the Milky Way at around 1 million miles per hour is one such event. The object, known as CWISE J1249, is not just any stellar body, but could be a low-mass star or a brown dwarf, an enigmatic type of celestial object that blurs the line between a star and a gas giant. But what's truly intriguing is how this object was expelled from our galaxy, likely flung by a cataclysmic event such as a supernova or an interaction with a black hole. The discovery of this object is not only a testament to the power of collaborative science, but also a window into the violent and mysterious processes that shape our universe. The object was detected thanks to NASA's Wide Field Infrared Survey Explorer mission, a space telescope that has been mapping the sky in infrared light since its launch in 2009. Among the many discoveries made with WISE data, this one stands out due to the involvement of citizen scientists, volunteers from around the globe who contribute to the Backyard World's Planet 9 project. These dedicated individuals, including Martin Katnick from Germany, Thomas Bley, and Dan Ceylon, were able to spot this faint, fast-moving object, which initially appeared as a blur across their screens. Upon closer examination and follow-up observations using ground-based telescopes, it became clear that the object was unlike any other known object. Its high velocity and low mass immediately raised eyebrows in the scientific community. The object defies easy classification. It could be a low-mass star or a brown dwarf, a failed star that never accumulated enough mass to ignite hydrogen fusion in its core. Brown dwarfs, while relatively common in the universe, do not typically move at such breakneck speeds. In fact, this discovery is unprecedented. None of the more than 4,000 brown dwarfs discovered through the Backyard Worlds project had ever been observed leaving the Milky Way at such a velocity. This anomaly suggests that the object might have been ejected from a larger stellar system due to a catastrophic event, such as a supernova or a close encounter with a binary black hole system. Adding to the intrigue, the chemical composition of this object suggests that it might be an ancient object, possibly originating from one of the first generations of stars in the Milky Way. This could make it not only a rare find, but also a relic from a bygone era of stellar formation. Hypervelocity objects are fascinating phenomena in astrophysics. These are stars or stellar remnants that move so fast that they escape the gravitational pull of their home galaxy. The concept of hypervelocity stars was first introduced in the early 2000s, and they have been primarily associated with interactions involving supermassive black holes, such as Sagittarius A*, the behemoth at the center of our galaxy. Unlike the massive O and B-type stars that are typically found as hypervelocity stars, this is a low-mass object. This raises the question, how did it gain such incredible speed? One prevailing hypothesis is that the object was once part of a binary star system. In this scenario, one of the stars in the pair could have been a white dwarf, a dense remnant of a star that has exhausted its nuclear fuel. As the white dwarf accumulated mass from its companion, it eventually reached a critical threshold and exploded as a Type Ia supernova. The force of this explosion could have been powerful enough to eject the companion star into space at a staggering speed. This theory is supported by the low metal content found in this object. In astrophysics, metals refer to elements heavier than hydrogen and helium, which are produced in stars over time. A low metal content suggests that the object is quite old, likely formed in a metal-poor environment, such as those found in the early universe. Another potential explanation involves gravitational interactions with black holes. If the object originated in a globular cluster, a dense collection of old stars, it might have been ejected due to the chaotic gravitational interactions within a system that includes black holes. These interactions, although rare, can be powerful enough to fling a star out of its cluster and eventually out of the galaxy itself. Regardless of its origin, CWISE J1249 offers a unique opportunity to study the physical and chemical properties of low-mass stars and brown dwarfs. These objects are usually too faint and cool to observe in detail unless they are relatively close to Earth. However, with this hypervelocity object speeding through the galaxy, scientists can gather data that would otherwise be out of reach. This could lead to new insights into the formation and evolution of brown dwarfs and other low-mass stars, especially those from distant and ancient parts of the Milky Way. This object is not the only hypervelocity object that has been discovered, but it is certainly one of the most intriguing. Other objects, such as the brown dwarf YSEA, have been observed exhibiting similar high-speed movement, although not as dramatically as J1249 object. Additionally, ancient stars within globular clusters have been known to experience ejection processes due to gravitational interactions with black holes or supernovae. In 2010, astronomers discovered a star traveling at an astonishing 1.6 million miles per hour, believed to have been ejected from the center of the Milky Way. Similarly, two stars discovered by Chinese astronomers, known as the Lama stars, are also classified as hypervelocity stars, demonstrating the variety of objects that can achieve such extreme velocities. These discoveries raise an interesting question. Could any of these hypervelocity objects pose a threat to Earth? Fortunately, the answer is almost certainly no. Objects moving at such high speeds are typically on trajectories that take them out of the Milky Way or through vast, empty regions of space. However, studying their movements allows scientists to refine models of stellar behavior and galactic dynamics, contributing to our broader understanding of the universe. The discovery of CWISE J1249 also underscores the importance of citizen science in modern astronomy. Projects like Backyard Worlds, Planet 9 demonstrate that with the right tools and guidance, amateur astronomers can make significant contributions to our understanding of the cosmos. The identification of this object was the result of years of dedication by volunteers, showing that the spirit of exploration and discovery is alive and well in the general public. As we continue to explore the universe, collaborations between professional astronomers and citizen scientists will likely yield more exciting breakthroughs. These discoveries not only expand our knowledge of the cosmos, but also inspire a new generation of stargazers and scientists. The study of hypervelocity objects like this one provides valuable opportunities to learn more about the history and evolution of our galaxy, and perhaps the nature of galaxies beyond our own. As we gaze up at the night sky, it's humbling to realize that there are objects like this hurtling through the cosmos at unimaginable speeds. Each discovery like this brings us one step closer to unraveling the mysteries of the universe. So make sure you like and subscribe for more news about the cosmos.